Hey everybody, Dr. Gilchrist here, and for my research method students, I very quickly wanted to go over how you can do correlational findings and correlational hypothesis testing within ESKI for Jamovi. So I want to kind of give you an example. In this particular instance, to kind of look at an example, I've managed to pull this data. So here we have a score on exam 1, and then we have a score on the final exam. Now, I've already kind of shown you previously how you can get a correlation coefficient. So we could choose to do this the long way. So we could get the z-scores for exam 1. So we'd need to calculate a mean and we'd need to calculate a standard deviation for exam 1 and the final. Then we would take our z-scores for exam 1, our z-scores for the final exam, multiply them together. Then to get our correlation coefficient, take that sum of the z-scores multiplied together, divide them by n-1, the number of pairs minus 1, and that will ultimately produce Pearson's R. Another very simple way that I showed you that you can do this is with the Correll function. So with the Correll function, we're going to go ahead and enter in our first array. Then we're going to enter in our final array, our second array, and we get a correlation of about 0.57. And if you went through the entire process with z-scores, or if you did this by hand, you would ultimately yield a similar result. But I want to show you what happens when you actually put this into ESKI for Jamovi. So I've already kind of done this for you. I have some results here, and it turns out, again, this is an instance where having a correlation coefficient doesn't tell us the whole story of the data. Really quick, once I'm done, I'll show you how to do a scatter plot in Excel. But here we're going to go to ESKI. And we're going to go to our correlation for a single group. So this is the same person with two different measurements. So we're going to go to that single group correlation. And here's what we're basically going to look at. Let me go ahead and move this over. And I'm going to move my head just a little bit. So here's what we need. We need exam 1 in our x variable. And we need the final exam for our y variable. So already we've got means, we've got 95% confidence intervals for those means, we have a median, and I'm going to go ahead and opt for extra details. In addition to this, you can see that there is a scatter plot. Now, before we do anything else with this data, I'd like to go through and just look through some of the findings with you. So notice that the mean of exam 1 is 87.8. The final exam is 85.8 for the mean. So they're not that different from each other. Here we have the 95% confidence intervals for both groups. We have our margin of error, the standard error of the mean, the median. So notice that the standard error of the mean and the margin of error were added when I clicked this box that said extra details. Here, we have the 95% confidence interval for the median if you cared. We have our standard deviation, we have our minimum and maxima, and we have our percentiles. Now, here is kind of what we care about, the correlation in this instance. So again, much like we find in our Excel, where we found a Pearson's R of 0.575 or 0.58 if we're rounding up, we also have that here. But here's what I want you to notice that we don't have in Excel. We have the confidence interval on R. And again, I didn't teach you to calculate that because it's complicated, and ESKI for Jamovi can do it for us. So here we see a couple of different things. First of all, notice that the correlation coefficient, that 95% confidence interval, it's in the negative and it's low. So in this particular case, the correlation coefficient could be as low as -0.17 and as high as an upper bound of 0.89. So we have a lot of variability in where our correlation coefficient's true value could actually be. And this should make us a little bit nervous. Now, if we take a look at the scatter plot, you can see that we don't really have a lot of data here, but there's a couple of other things that I want you to look at. Here is our confidence interval on R, our estimation figure. So again, 1 is our upper bound, -1 is our lower bound. And remember that that 95% confidence interval on R is going to have a bit of asymmetry to it. But I want to show you a couple of other different things that you can do within ESKI. So first of all, we can do a regression analysis. So I can actually choose to do a scatter plot with a line of best fit. So this would kind of fit with the regression line. Now, with the scatter plot options, another thing that we can do is that we can cross. We can do that cross where we have the quadrants through the mean of X and the mean of Y. Notice in this instance, we have more matched than mismatched, but also notice there are a high number of mismatched quadrants, so that's kind of dampening our correlation. We can also include the correlation coefficient on the scatter plot itself, such as right here. Now, another thing that I want to show you with the estimation figure options, there's a box for hypothesis evaluation. So we can actually see if this correlation coefficient is significantly different from a null hypothesis, that there is no relationship between the two. Now, here's a couple of different things when you do hypothesis evaluation. So here, you can see it here. We have the effect that they should not be different. The null is that they're not different from each other. Here's our 95% confidence interval on R, and R is contained within the confidence interval, and more to the point, the null hypothesis of R being 0 is contained within the confidence interval. So in this particular case, we cannot say that the R of 0.58 is significantly different from 0. There's too much variability in our scores. There's also not enough data. This particular person might be a little bit of an outlier in this instance. So we're going to fail to reject the null, and this is associated with a p-value of 0.108 that is not statistically significant. Now, here's kind of another way to look at it. We go back to our estimation figure. A null is basically marked here in red. So here the null hypothesis is that there's no correlation between these two scores. And you can see that the 95% confidence interval contains our null hypothesis here. So in this case, we cannot say that it is significantly different from 0 if you are interested in null hypothesis testing. So this is actually pretty straightforward in ESKI. Really quick, when you're looking at your data and you want to look at confidence intervals, if you double click on this header, remember that your measure type has to be continuous for both of those variables for you to actually do a correlation coefficient. Oh, really quick, returning to Excel, I mentioned that the Correl function can give you Pearson's R, and it's really helpful, but the major problem that we have here is that this doesn't really give us the best scatter plot of our data, and I would like to show you how you can actually do this. So if you go to Insert, you can go to a chart, and you can basically pick a scatter plot. If I do this, here is my scatter plot. And you can kind of see this is not actually the best axis that we can kind of work with here. So let's go ahead and fix our axes. So in this particular case, we want the maximum to be 100. And I'm going to go ahead and move our axis to 50 so that we can see that it's failing. We're going to do those axis bounds for both of these. In this instance, we're going to go ahead and fix this axis as well. So we're going to put this at 50. And again, we're going to put this at 100. So now you can kind of see that things make a little bit more sense in this figure. The scatter plot looks a little bit more reasonable in this instance. We're going to go ahead and make the minor unit 5 for this one. We're going to go ahead and do the same with this one. We're going to make a major unit 10, and we're going to go ahead and make a minor unit 5. There, perfect. So now we can see a little bit more of the scatter, and we can also see that we have that particular outlier that we don't necessarily want. Now, when going into the scatter plot, we can actually do a format plot area, and we can do a couple of different options here. So in particular, we can add a chart element. In this particular case, we can add a trend line through the data, which is very similar to the regression line that we obtained. But this is basically if you had data and you wanted to look at the correlation, this is a little helpful. If we go to the trend line options, we can also display the equation on the chart. Now, this is a regression equation. This is not a correlation coefficient. And likewise, if we go back into our data, you can see that the regression equation is also reported here. So just to be really clear, this line of best fit that you see in this trend line is not for the correlation coefficient. It is a regression line based off of the data. But you can also do this in Excel by going and selecting your data, picking insert, and making sure that you pick this scatter plot right here. So hopefully this will help you out as you're kind of looking through your data, and I will see you all to talk potentially about proportions and frequencies. I might choose that over one-way analysis of variance, but we might have to change a couple of things. We might have to change our homework assignment, so we'll kind of see what y'all are thinking, but I'll see you back in December. Bye, everybody.